All right. How you doing, friend? Welcome back for another week of Haskell hacking with yours truly. The agency is ready. We're going to continue this week with our text adventure game that we're developing in Haskell. Just a quick review of what we got done last week. Why not? Let's just open up a terminal here. Throw stack exactly adventure engine. All right, so we got this nice little rendering going of the kind of old, ugly text that we had before, which we're going to fix up and clean up, make look nicer, because now we got this nice, slick vector-based UI. We don't need to like add these like little text dashes, and we could probably even turn over the inventory stuff and render that in a different place in the UI. It's good enough for now. Last week we were working on the input though, which is what we're going to do. We're going to finish up this week for sure. Basically what I want to be able to do is take our commands here. We want to be able to press enter and update the game state. Right now we just kind of render the exact text we get in from that we just hard-coded into the game engine right now, but eventually we're going to do that. And then also I want to make this kind of render from the bottom up. So the newest items at the bottom here, and then make this scrollable, which I think is already done. Like we just keep, yeah, we got scrolling. So I just wanted to scroll from the bottom up instead of the top, adding items at the top. So that might be an adventure to figure that out. And yeah, and then maybe if we get far enough, we'll get to breaking up the data here and be able to render it out into a nicer UI layout. And that'll be like a kind of a V1, I guess. And let me know, chat. Let me know. I'm curious to know if we want to like explore. Hey Barry, how's it going? Nice to see you. Thank you for coming and stopping by. Barry's an excellent streamer. If you haven't checked him out, fam, you should totally do it. Getting a link to our Discord server here, and you'll find him as Troptical. It's awesome. So yeah, this is Monomer. So we're gonna work on the input part today, and then we'll see if we can break this up and make this into a nicer engine. But I was saying, chat, let me know if you want to try the same experiment using this like text adventure engine and adding a different GUI front end. Maybe we want to try doing Qt, maybe we want to try GTK, or some other library that you want me to give a shot on stream. Happy to do it. Happy to try it out and experiment. Or maybe we continue down the road with this particular game and we make it into something. So this one is a Monomer. Monomer, hopefully I'm saying that right. Oh, my cat. Sorry, my cat just totally jumped into my background and knocked it over. It's not a fake background, it's real. Yeah, so Monomer is like a vector-based library. That's pretty new. The nice thing about it, I think, being a vector-based library is that you have a lot of flexibility in how it looks. It's super simple to write your own custom widgets. And it's cross-platform to a degree. It'll probably be pretty cross-platform for most of the popular platforms available today. So it's based on some underlying libraries called NanoVG, which is a C library that Monomer is built on top of that does a lot of the rendering stuff. We just get a nice Haskell interface to it. It's pretty cool. And the architecture is very modern feeling, quote unquotes. I'm not sure I like the term modern, but that's kind of, it's newer, and it's kind of using newer trends in UI architecture, GUI architecture. It's using the Elm style architecture, which is a bit different from, say, GTK and Qt, which are very mature, very good libraries in their own right, in their own ways, just have different ways of thinking about things, and different designs. So yeah, I think we're almost there where we have something kind of usable. If we go down this route of like trying out the different GUI toolkits, that's kind of where I think we should get it to, is like, it should get to the same rough point as the terminal version of this that I originally wrote, just in the GUI. Cool. So let's get down to business and get that input working. So last time we looked at this, I believe the optimal way of getting input into this thing is not to search through the widget tree and pull out the text that the user had entered from into that widget, but to use the onChange event of the widget itself to update an input buffer in the game state. That's kind of my thinking right there. And then when we receive the app input received event up here, so our app code gets to handle that. Basically, it just has to look in the game state for that buffer and then do the update the game engine state and all that stuff. So yeah, very, very Elmy. Hugely Elm inspired. Which is not a bad thing. I had some pretty good experiences trying out Elm very early on when it was still really new, and liked it. It was all right. It's pretty good. I don't know what the current state of the Elm world is these days, but I hear it's still going around. And they're still working on stuff, and they're making better things, and it's bleeding over a bit into the Haskell community and other functional programming communities. So good on it. It's a pretty good architecture, I would say. But I don't have like a ton of experience with this stuff. I build GUI applications for eons and have used all kinds of different toolkits. I think the Elm one's pretty good. So why don't we go to the game state first? That's in engine, and we'll just add our input buffer there. Where'd my game state go? There you are. Oh, Haskell Kitty's looking to jump up on my lap. There's too many cables down there now. Yes. Please be careful. Okay, input buffer. Game state input buffer. Boop. I'm not sure what kind of data we're going to get from onChange. We're going to get like a character. So should we make this a text? Or are we going to get a bytes? Like, is it going to be like a character and we have to append to a byte string? Or is it going to be a text that we can just append to our text? I don't know. You switched to PureScript, Bear. Yes, I've been following a bit on your stream and watching some of that PureScript stuff. Also very cool as well. Do they have architectures that are Elmy as well? Yes. You can't walk on that. No. Lay down, kitty. Oh, she just loves hanging out on the stream. Okay, text. Okay, so that's the input buffer. Let's look at the onChange stuff. I think we can look at this, maybe a tutorial. I don't know. Maybe in examples we'll have one. Maybe not though. Who knows? Who knows? I've been kind of like going through using these example programs they've built to help me understand how to use the library. The documentation's okay. Doesn't always tell you like how to wire things up very well, but it's all good. It's all good. So that's all kind of like the top level types for that. I wanted to look at main. Input. Input. There we go. Edit fields. Okay. Keystroke, enter. That's the save action. That's good. Text field. Okay. Yeah, this library is also very lens heavy as well. And it's pretty useful. My lens knowledge doesn't go much further than this little guy here. The set one, which is like the tilde dot or whatever, percentage dot. That's about it. Yeah, this one. Dot tilde. The and. But it can be quite useful because it can make your code a lot more succinct. And especially when you have like nested things. I find like if I'm going more than 2 things deep, I almost always want lens. Okay, so let's see. We got to give some kind of function there. And so that's our input buffer. Let's go back to the UI. Input field. Yes. That's right. There was a different kind of input field that takes the onChange function in line, if I recall. Widgets, singles. Text field, yeah. Oh, and even in the configuration options for it, we can do event arrays when this is done, on change. Event arrays when the value changes. Okay, cool. Cool. Not sure we need that, but we do need this one, I think. Text field V. And it emits a widget event. Okay. How do we get the darn text out of the input field, though? That's what I need to know. Maybe I do have to, maybe we do have to traverse the widget tree to get text out of the darn thing. Text field V. Let's search for an example of that here. Text field V. We could look at the tests. Yeah, that looks like the only code example we got. EVT. Okay, test events. Text changed. Got focus. Lost focus. Maybe it'll give us a text thing. Okay, and look, this is a test model as well. It has like a text value, kind of like what we have in our game state. This is looking good so far. Let's look for that text field V. Text changed. Sweet. Okay, cool. So we just plop that in there. Sweet. Okay, cool. Let's do that. Input entered. Let's change that. We'll have to change that to input entered, I think. We'll do that later. But for now, we'll do app input updated text. I got to handle that down here. Why don't we handle that now? App input updated. And then we just change the model. And this will be the input buffer. Yeah. And that'll be, we'll change it to text, txt. And we'll kind of make it look like that. Nope. We'll just update. We'll just set it. Yeah. I don't need to cons it on anything. Good to change that to model. And that should be good to go. Yes. Excellent. What's the type error here? Oh, couldn't match game state. All right, not dollars, sorry, and. There we go. Cool. My bad, but we got it done. Input updated. And takes a text. So now input field shouldn't be a field D. We can change that to a text field V. And we could put in our input updated type there. I think something like that. Not quite. And that's because I got the tops wrong for this. That should be fine. Oh, yeah, I was using point freestyle here. I think we're going to have to stop doing that. Perhaps. Config. Because I guess the order of arguments is probably different to text field V. Might not even take a config. And if my popover would show me the actual type, that would be great. Right, it takes the callback function as the second argument. And then the configuration. All right, so that'll be, our function will be app input updated. Yes, and config will be the third one. Yeah. And now what's the problem? Add a reduce, sure. And now could match type E with app event. Yes, I think I might need to... I might need to get rid of this function altogether. I think we were only wrapping over this for reasons because we didn't want to do all the widget value stuff. Yeah. Instead of input field, let's do it here. Text field, duh. And app input updated. Sorry, text field B. Aha, there we go. Yeah, I think it was just there are two different classes of things. That function in particular, it probably has a particular use case that is meant for, and I just wasn't using it right. And I was just wrapping it, hacky code. But this feels a lot better. So I think widget events are like a separate thing from your application events. So probably just get rid of that now. And we should probably have kicked off our file watch build there. Oh, sorry. Well, I wasn't in my projects folder for Adventure Engine. I was about to eat up all my disk. Stack build, fast, file watch. Okay. Now we should be able to, well, as long as we know how to do it, because, oh, we got a couple of type errors still. Oh, we got to fix before this will work. Probably an engine. Yeah, jump to the next one. There it is. It's right here. Game state needs a default input buffer. Don't you, friend? Yeah, you do. That's probably just a accidental. Nope, nope. How did I get that wrong? What did I do here? I guess it's just been letting me get away with that. We should probably fix that. Did I mean to put it? I guess I don't need that. Just get rid of it. Seems happy. Okie dokie. Okay, we won't be able to see this. Oh. It's chewing up our input when we do this. Like I'm typing away here and it's whoop. Okay, let's see what's going on with that. But we need a way to like see what the state is doing. I wish you could download more space from the internet. That would be great. I mean, you kind of sort of can. It just takes a while. A couple of days. Good old sneakernet. And I think even to this day, if you do the math, the sneakernet is still faster for extremely large volumes of data. And cheaper. Okay. Yeah. So we need to like see what's going on here. If I need to append the text from the event. Right, now I do set it, yes. It's true. And it might also want a lens into that buffer as well, like the input buffer, the widget. Something like that. It's probably where we're going here. I mean, if we look at the test, it's probably showing us how to use it too for it. That's last event should be blah blah blah. And T string, event move line L. Should be a dog. Oh, well, maybe we can get input history with this too. Cool, cool, cool. Yeah, so I guess if it like fires off an A and then a B, we get two different events. A and then AB. And we have an event string, the starting string, this is dog. Another event text with a question mark, adds it to the end. Move line L, and then event T is space. Is this a dog? So something, it's something. Maximum length. And focus on blur, on change request. Let's just try the plain text field now that we know, now that we have an input buffer and a lens to point it to. And then we can configure the on change or, yeah, with that one. So that's kind of the convention here, Barry, is that the underscore ones are like the widgets that accept configurations. Don't worry, I don't have a whole lot of clue either. I'm just figuring this out on stream as we go. That's how I do a lot of the stuff here. But we get somewhere. We make progress. We mess around and we find out. It doesn't quite rhyme, but you know what I'm saying. We mess around and find out. We experiment. We try. Okay, let's try text field v. Text, yeah, we're doing that. This one just takes configuration. Well, that's just because you don't know about that I have overloaded labels. Hopefully it's on my path. Okay, The only thing I don't like is the text field thing. I think what it might be doing is like it's doing the app input received and then it resets the state to like maybe this when we should perhaps use a regular text field. Give this the input buffer lens as a parameter, and that's those lenses, Barry, are basically how the widgets remain very generic over the users, like our models and other data structures. So the library just needs lenses to go get data out of the things we provide it, which is, I think, a little bit confusing at first because lens can be pretty confusing, but it seems like a pretty nice way to write a library, perhaps, for this sort of use case. And so the input text field underscore allows us to pass in the configurations. And the configuration we want is to give on change. Updated. So I hope maybe that works. Mess around, find out. That's a little better. Okay. I'm liking this. Pop, pop, pop. I'm gonna press enter. Okay, cool. When we press enter, we should probably reset the state of the input text area as well, somehow. But we're getting input. So that's good. Checkpoint. When applied, this change will append, add the input updated, app input updated event. This event, we also added the input buffer to the state and update it on change. Cool. Next step. Let's update the game state. That's done. Done for that. All right. Now we need to look. Now that we get the input buffer, we need to, when we handle the handler for the input received, app input received. So instead of appending a plain text thing here, looks like we can return multiple things. One of those things could be a model and maybe another event. If I'm not mistaken, I think that's the way it works. And the model here, we have a way of getting the rendered view. So got to render the view, and then append that view to the rendered views like this. So instead of this string here, I get model here. So in order to do that, we go to the engine. It's the render room function for the most part. For now, anyway. This will have to be fixed later, but in order to call render room, we need a room, a list of game objects, a list of exits, a list of a whole bunch of things actually out of the game engine. Oh, out of the game world, which is in the game state. So I'm wondering if we could write a little wrapper function around that to make this nicer. In here, we can just kind of like do what I want to do is render game view, something like that, and just pass it in the model, right? Which will have the input buffer. So it'll have to handle all of that stuff. And then we just append it to the list of rendered views for now, until I figure out the other thing. And should be good enough. Now, of course, this function isn't defined yet. And what do we got here? So I'm going to have to change my checker here. It's back to Haskell stack GHC. We're getting this because I messed something up. What did I mess up? Oh, indenting. That's what I messed up. Yes. Pop. There we go. Okay, there we go. Yeah, that's the one. Variable non-scale. Render game view. It's doesn't exist yet. We can go ahead and write that now. All right, takes game state. Returns text. Cool. So let's fill in this hole then. The game state has 3 parts, or 4 parts. It's got the list of verbs, the world, that's what we need to render, and our input buffer, which is the command we need to handle. So we can ignore the verbs, we need the world. Rendered views, we can ignore that. And we need the input. Now it doesn't think... Oh no, it was just being slow. Okay, so that should be good. Let's look back at the engine. There. World, current room. What does the REPL do? Because we also need a new version of the world to return in the model when we modify the state. oh, actually calls render on the whole world. We do have a function for that as well. So we're essentially like kind of moving this around here into our GUI layer instead of rendering it in text. We kind of have to do all this stuff here kind of in one kind of go, right? One step. And that's kind of how like this, at least for now, I might want to break it up later, but how this game engine kind of works is like it modifies everything in one step, right? It takes the user input, parses it, figures out how to handle it, tries to update the world. And if everything was copacetic and good, word of the day, copacetic. Copacetic? Sorry. Copacetic, something. Then, yeah, there you go. Copacetic. It's kind of one of those words I've always just used and never really knew where it came from, but it's an excellent order. It has an interesting history, and that nobody agrees where it came from. Should look it up. There you go. Okay, so in this case, actually, what we might want to do here is not necessarily just update the rendered views. Let's just return a whole new model and do everything inside this function. Update game with the model. Yep. Change that there. Update game. And this will take a game state and return a new game state. Cool. That should be better. Okay. And I'm going to need a better error handling architecture for this too. We don't have that yet. We don't need it just yet. Let's focus on doing the change we want to make here. So when we update the game, we're going to handle this. How are we going to handle this? This works so well because it is inside. Well, we do have a lot of code. Let's just keep going. Okay. Yes, let's call handle. Okay, we got the raw input from the input buffer. So just as we do here. In fact, I'm just going to blop that over here. Who cares, right? Who cares? Let's just go. Let's just do it. I don't have a do case. Okay, I'm going to do that there. I don't have do's. I don't have do's anywhere. I'm not in a do thing here. Oh, I can't blop it over here. Let's blop that first part though. This couldn't blop properly because it's bumped over there. And these are all sophisticated technical terms. Looping and blopping. Okay, in the left error case, we can't really do that. I'm going to come back to that. In the right case, we have a new version of the world, which is good. And then I'm going to bloop and blop this over here. Bloop, blop. Blip. Bleep, bleep, bloop. Bleep, bleep that over there. Blop this over there. Okay, and that's going to be something as well. I don't know yet what. But in the case, we do have rendered. We know what we can do here. I have an equation I can stick in this hole. All right, we have it over in GUI. What we were doing previously in GUI was we were basically appending it to the list of rendered views. So let's pull that into scope. All right, and what we want to return here is game state. We're actually going to need the verbs, even though we're not going to do anything with them other than pass it through. Might be a better way to write this, but I'm just going. World prime, the next state of the world. Rendered views, right? We're going to put the rendered room const onto that. And we'll update the input buffer back to the empty text. That's what we'll do. Perfectly cromulent. Now we just need to fill in the holes for the error case and what we're going to do with those. We also didn't handle G here. What's G? Game state. Well, I can pull that into scope like this. Raw input, of course, is our input buffer. Should fix that. Thank you, GHC, for, like, this is why we program in Haskell. It's so good. Input buffer, not in... what's the problem here? Tell me. Couldn't match the type. Ooh, oof, oof, oh. So many things. So many reasons why we can't do that. Oh, maybe because it's not input buffer, it's just input. That could be a good reason why. Now, where mistakes were made, and was handling strings before, so I don't think we need the t.pack anymore. Probably don't need apply, I don't think. Yeah. Okay, that's awesome. Much better. So in the case we have an error. Now this is cool. We could just do G, where maybe we have like an error list of errors that we can render. So why don't we just quickly add that right now, because it's not too hard to do. It's pretty straightforward, pretty simple. I know it's not kind of like the main change we're supposed to be working on right now, but we might as well just do it while we're here. Super duper, right? No, no. Yes. Line that up good. And get back to where we were. So then we could just do the game state errors. Just the record update syntax. Not a problem. Right, or we can use, you know, we can be consistent. Use lenses more. Errors. Should be dot tilde with error appended to errors. And that might need like a text show instance or something. And what's the problem here? Nope. Yep. We have to update this part here. So errors. Ease. Conflicting names with our lens. Probably fix that easy. Game errors. That'll fix that. Game errors, and then I can just call this errors. That should be fine now. And errors here as well. We might even be able to do the same thing down here at this, but that should work now. Oh, and default. The default state. Default game state. That should fix that. No, that's good. Yeah. Yeah. Let's do that. Instead of pulling out the parts necessarily here, we can just do this as well with rendered views. And we set rendered views to rendered const onto. We have rendered views in scope. Naming problems. RVs. Yeah, what do we got here? Wow. Right, text error. Game error, and I defined it as text. Let's do it what the type it actually is. Let's not actually do like showing or anything like that. Let's make it the game errors. Taking a little bit longer on this change than I want to, but that's okay. We're almost there. And that should fix that. Maybe LSP has died on me here. But in this case, we got the same thing as well. So I'll just fill that in. There we go. Render error. Where are we going here with this? Game could not match type. Expected listed. Oh, did I? Yeah, I made a boo-boo. Not game state, game error. Silly me. What am I doing? Okay. Beautiful. And then there's, what's the rest of this stuff in GUI here? That's just my fly checker being annoying because it's not picking up on my default extensions. So we'll get rid of that. Tooling problems. Fun times. Okay, and are we actually building? Are we green on the build? My buffer, yeah, we are. Okay, so let's try it out. Skadoosh. I don't know if that did anything. We can walk front door. Cool. Okay. We're getting some interaction here. It's not quite working the way I want it to, but it's Almost there. So look, we went to the main hall from the front porch. That's like our next thing, right? Now I want that input to go away after you type enter, which I think we're pretty close to being able to do. So we'll just clean that up quickly, but that's great. So now we can walk to the door, right? We might want like some sort of read line history for this as well. But there we go. Oh god. So, in the case where we finally render something, we're just rendering the rendered views, but we need to update other parts of the game state as well. So what I'm wondering is, can I combine these lenses, these updates together? So rendered views and input buffer should be set back to the empty text. Right, walk front door. And there we go. That fixes that. That's good. Lock door. That's not quite working. Something's wrong with that, but awesome. Something. We got to still be able to render errors. We haven't been able to figure that out yet, but I see a Brawley bucket. Look door. Does that work? No. Cool. It's getting there, folks. It's getting there. Okay. Is that checkpointable? Yeah. It's still kind of buggy, though. But is it buggy, like... It might not be so buggy if we have a way of outputting the errors. Or rendering the errors. So I'm going to say checkpointing. Let's do it. Let's create a commit. So when applied, this change will update the game state based on user input. When we receive the input received event, update the rendered views and the game world. Oh, I think I know what's going on. I think I just figured out the error. It is a bug. We're just appending the rendered errors in the new game. We're not also adding the updated world. World? Yeah, I can't figure that out because the name shadowing. Which one I mean. So let's do that again. We'll shorten that one to W. Just so that we can do a W here. Just, yeah. That should be the right way to do it. Walk front door. Walk the door. Oh, dang it. Okay, well, maybe there's something else going on that I don't know about. I thought that was where they'll be, right? I type walk front door again. Yeah. Something about not updating the game state here is what's happening. Oh, we're not W. We want world prime here. Get the program, dude. So Haskell's not going to prevent those kinds of bugs, of course. Those are noggin bugs. Oh, I got an issue here. I will be right back. Okay, sorry about that, friends. That was just my elder cat coming down to visit Haskell cat. Elder cat and Haskell cat don't get along. Okay. So this should fix it, I think. I think this is what we want here. Walk front door. Bam. Walk door. Bam. Walk front door. Bam. Look at the Brawley bucket. Oh, that wasn't the right one. Examine? I forget all the verbs that we have. There you go. Examine. Yeah, examine Brawley bucket. There you go. A rusting iron bucket. There may be some Brawleys in it. Look in Brawley bucket, I think was the verb for that. Inside the Brawley bucket, you see Brawley. There you go. So that's kind of our text adventure engine. That's kind of the experience you get with the text version of this on the command line if you're to play this in the terminal. Not a whole lot to it so far, but it's working. Take Brawley from Brawley bucket. Cool. You are now holding the Brawley. Right. Now we're on the front porch. Then we can scroll back. We see, like, our history through it. Minimum viable, I would say. You could sort of, if we finished, like, the game part of the game, you could sort of play it this way. It's not great, but you could. So that's usually what I mean by minimum viable. Like, the main interaction kind of works. But we need to improve this. There's improvements to be made here. But this is the checkpoint that we want. This is the good part. This is what we should check in. So let's do that. Update the game state. On input received. So we update the game world. Append a rendered view to the game state. And Bob's your uncle. Oop. How come I didn't check that in? Well, let's just fix that quickly. Rebase interactively, squash that down. Make sure nobody ever sees that mistake. There. Cool. Done. There. Okay, now we can talk, we can check that off our to-do list. Sweet. Not only do we need to render the inventory, we need some better things. Well, errors, right? Render errors. Game error. It's got to render the game errors. What else do we need to do? Right, we need to. Well, I want to break up the. Thing. So when we render the game view, I think this should be a data structure, so that not just text. So that the front end can, or the GUI here can render it however it wants, and it can pick out the pieces. It needs to render the different parts and different widgets if that's what it wants to do, if that's what we want to do with it. I'd also like to remove the UC, the items. Well, maybe we could leave the items that are here in the scene. I'll call it like the scene, the rendered view, right? Maybe that's what we call it. I like that better. Rendered views to scenes. Yeah, so maybe we'll leave that in the scene, but we'll leave like the inventory and leave the inventory out of it. That could be off to the side. That would be handy as you're playing the game. Just because like you're going to see it repeated over and over again. But the rest I think could be in the scene, like the possible exits, what's the objects that are in there, what the player sees, the title of the scene, like what's happening, that kind of thing. Those should be all part of it, but they should be broken up into a data structure. So I don't know if like, in chat, you might want to fill me in on how you're feeling about this, but this is kind of where I'm thinking we're starting to getting to improving the engine. You know, we're getting to that territory. And developing this more fully with this GUI toolkit. But if you want to explore alternative toolkits, we have to know like when we want to say when in order to make our comparison. When is far enough? Right, because different toolkits are going to have. It's going to be fair. This is like a couple streams, 2 weeks ish. So I can imagine us spending 2 weeks on QT and maybe 2 weeks on 2 sessions on GTK. Maybe we can do. I don't know. Maybe if we can do like a web one. There's a potential. Or if there's a way to do Electron. It's not my favorite go-to, but it's there. Good try. We have the libraries in Haskell to render views there. So I don't know, maybe I'll put a poll up. We'll just keep going for tonight because the stream's gonna end in, I don't know, 50 minutes or so. So we'll just keep going with this for now and just see how far we get. And then we'll make that kind of like the checkpoint for comparison, maybe. If we still want to do that. Or just keep going. So let's break up create scenes. And I wanted to structure containing the text, what the player sees, list of objects the player can interact with, and the exits. Let's remove the inventory. Scene. And that gives us another to-do item is to render the inventory. Oh, we have the render the inventory. That's already there. Cool, cool, cool. Render gamers. Rename rendered views to scenes. Yeah. And then in addition to that, we'll need a scene widget or something for rendering. Maybe we could just build it out of the primitives. Maybe we can write custom ones. Use a couple different fonts, you know, make something fancy looking. Depends. All right. Okay, so let's see. First things first, I think rendering the game errors will make working on this easier and better. So we should probably do that first. So let's work on that. Okay, so we have the game errors listed out there in the GUI. Let's see. How do we want to do that? How do we want to do that? Let's think about this for a second. I don't want to give up too much real estate to game errors, because they might be ideally pretty temporary. Where'd my pen go here? Oh, not that. Ah, dang it. No. Things are going cray. Where'd my game window go? There we go. I don't want to give too much real estate to errors because it's just annoying. So what I'm thinking is maybe we can have something like a status bar at the bottom here where we can put it. And just like have a little space there for it. That's one idea. The other thing we can do, at least with the input, so there's one kind of error. There's two kinds of error. There's a bunch of different kinds of errors in this game, but engine so far. But there's like input errors, and there are like runtime errors. Those should be pretty rare. And might just because we designed like the game data wrong. So those would be hopefully caught in development before they get thing, but there's runtime ones. And I think there's just like general. I think that's actually mostly it. Just input and runtime. And the runtime kind of includes bad game state. It includes just, like I was saying, bad game data. If you build the world wrong, you can do kind of things like that, and just informative ones, not necessarily errors like with the game engine or like something going wrong, but like and not necessarily input, like the user didn't input an available verb or something like that, but they tried to pick up an object that doesn't exist, right? Or they tried to walk somewhere that doesn't exist, like an exit that we don't know about, and things like that. So I'm kind of thinking like a status bar might be nice for that at the bottom, or yeah, for all of these ones. Input's the one that's kind of special. Input, we can, text fields seem to have this cool thing in Monomer at least. This might be special Monomer. I don't know if we'll be able to do it in the other toolkits, but it has a validation thing I think we saw there, where it can kind of like change the state of the widget to highlight that there's something wrong. And I might want to like look into doing that for that. I don't know if it can like pop up. It would be really nice if it could like just pop up like a button or something like that. Oh jeez, sorry. I think I must be in touch mode here by accident. I'm just flipping around here. But you know, like if you started typing in a verb that like didn't exist, if it had like a little pop over kind of like, you know, kind of mark here, that would be pretty cool too. Like it would just be like, yeah, you know, X is not a verb. La, 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 la. That would be kind of nice too. Right, because then it's tied to your input visually. You can see that. It's not like the game engine talking to you necessarily, and it's kind of immediate. It's where your focus is when you're typing for the most part. So kind of like that. I'd really like to be able to do something like that. But let's just, for this first MVP on this though, let's try... I don't know how to do this because it's like a list, right? Let's just try rendering them all out. Like underneath the input, maybe text field here. And we'll figure it out from there. At least we'll be able to see them, right? And then we can make it better. A minimum viable step we can make towards our goal here. Okay, so when we're building the UI, we have the text field at the bottom of this list, this VStack list. Let's create another VStack of labels for the errors, just like we do with rendered view labels. Wrap that in a scroll. Maybe there's a way we can put a fixed height on it. Rendered errors. Or rendered error labels. Yeah, this seems a little more consistent. let's put that here. Rendered error labels. And that's going to be a VStack. We'll pretty much cover that code there. Intersperse. Whoa. Not that one. Intersperse spacer with the map of rendered game error. And we'll get the list of those out of the model. Game errors. Cool. So that function is not in scope. Let's do that. Rendered game error. Takes an error. Creates a label. Do we want to be multi-line? It could be. Got some basic styling. I don't know. We'll figure out the styling in a moment. It's not text though. We'll just show it for now. It seems legit. And we're too legit to quit. It's bad. That's terrible. I'm sorry. Isha, let's try it out. Okay, cool. There we go. Unrecognized verb. Well, that was recognized, so that's cool. Lock front door, right? That's cool. Look, we tried looking at the Barley bucket, but that didn't work, so maybe now we'll know why. Exit does not exist, Barley bucket. Okay, so look means look at the exit, not look at the thing, which is kind of, I don't know, maybe a game design issue, which we can fix. Because the engine's, my idea with the engine was that it was just going to be a lot, very data driven. So that, you know, if you wanted to write your own adventures for it, not a problem. Here's the data format. It's just JSON. Bob's your uncle. So look, maybe, and you'd be able to define your own verbs and things like this as well, which we haven't figured out. I haven't figured out how to do yet. Yeah, I kind of stopped working on it. So, yeah. But maybe we'll keep going with it because, you know, it could be pretty cool. Especially with like this GUI, like this could be pretty sweet. And with the customizations options and the theming options, we might even be able to create like a nice little level or, you know, game creator environment for game developers who want to build their own games with this, and maybe we can build it ourselves, you know, on stream, and we could do some game dev in Haskell too. Why not? That could be a fun avenue to go on. So yeah, there's the errors. And that's how that looks when they're stacked kind of vertically underneath the thing. If we keep adding a bunch of them though, it's pushing this up. And like it's pushing that down again. So even as a minimum viable error buffer thingy doohickey, I think we should like limit the size of this. We don't need all of the errors ever. I think they should be transient. This is usually just like an input mistake, something like that. Something simple. And even when the user saves their game, they're not going to save all the errors and all that sort of stuff. So let's make those transient. And let's also fix the height of this thing so that the scroll doesn't push up, like it stays a fixed size. So let's add a couple of subtasks here. And fix scroll area size. And ephemeral fixed length thing. Okay. Let's work on the scroll area. Well, actually, this is a pretty good checkpoint, so let's checkpoint that, and then we'll work on the next issue of fixing the scroll area size. So stage it, add commit. This will add game errors. Render game error. Will, when applied, this change will render game errors below the input box. Sweet. Monomer, we're gonna have to look up how we can configure the scroll area and if it offers us a way to fix the size of it. Otherwise, yeah, maybe we'll have to, I don't know. Let's look at that first. I think it's under containers, scroll. Configuration. Wheel rate, bar color, bar hover, bar width, thumb color, thumb header, thumb width, thumb radius, scroll overlay, scroll invisible, scroll follow focus, and scroll style. Ooh, no. I don't like this. Okay. So scrolling, it's not scrolling's responsibility to figure it out. Like restricted size, I guess, maybe? Maybe there's another way to do it, though. Yeah. Let's see, what else do we got in containers? Box. Base. Draggable, drop target, drop down, grid, draw keystroke, scroll, select those split stack. Switch tooltip, Z stack. Okay, let's try box. What do you got for me, box? Container for a single item. It provides alignment options. This allows for the inner widget to keep its size while being positioned more explicitly, while the box takes up the complete assigned by its parent. In particular for containers which do not follow size rec restrictions. Oh, maybe sizing can be something we can do with styles. It can be used to add padding to an inner widget with a border. It's equivalent to the margin property in CSS. It's a web thing. Also useful to handle click events and complex widget structures. Okay, what can we do with a box? Ignore empty area, size rec updater. Line left, center, right, top, middle, bottom. I'll click events, expand content. Okay, maybe not. Maybe not. Maybe sizing is a style thing and not necessarily a widget thing. How do I figure that out? Monomer. Styling. Text, padding, border, and radius. Color, enabled, and visible. It doesn't really tell us a whole lot in the documents. Well, the only other thing I can think of is limiting it to just one, the last error. And at least the widget will only take up as much size as it takes to render that one thing. And hopefully the errors won't be too bad, too long. Yeah, I wish there was like a way to fix the size of it. As an example, maybe in to-do. I think to-do, the list in this app, the list of to-do items will just grow, and it'll just grow and grow and grow and grow. Let's see if we can find something like size. Text size. Text size. That's it. Height, maybe? Might be a word. No, not finding anything on that. Height. Well, maybe. It's turning up something here. Oh, sweet. It does. Okay, great. Great. Okay, height. All right. I like it. Return fixed height. Okay. Let's try it then. Style basic. Height 20. Is that a thing? It's compiling. Could be. Okay. Let's try it out. I still have it open. Up. Okay. Left. All right. It does. Look at that. Oh, it's fixed. Okay, we can scroll them. And it keeps the size. Okay, cool. We probably want some, like, buffer padding between the top of this thing and the input box, but otherwise this is looking pretty good. And maybe 20 is not quite enough. But yeah, there you go. All right, sweet. I don't know. 28. Padding 5. Okay, looking good. Yeah. There we go. That's looking nicer. Check. Done. Awesome. I love it. Okay, minimum viable. So when apply this change, we'll add an error. We'll style the error box We'll fix the height. The error scroll box. That's how we'll say it. Sick. Okay, to do. Done. Hey, we're making good progress on this tonight. All right. Make error buffer ephemeral. Fix the length. Only show the last, say, 5 errors. Maybe 3. Okay, let's work on that. And do. So yeah. So basically, I think we should do that in these left error cases. We need like, and they're both the same term, like they're both the same equation. So we should have a function for doing the thing in both places consistently the way we want, instead of having them kind of like this. So I'll just add a little where update game errors as a function there. Some kind of type. Bip. It's not going to be the right type, but that's fine. It's totally fine. And that's just going to have update game errors. That should take G, the game state, and the render error. And same here. Since they're both the same, we should update them the same way. Errors, G and error. They're also the same type, which helps. The errors. That's good. So that should be a type error. All right, and that should give us the type of what our function should be, which is game state, game error to game state. Game error to game state. Now, you don't normally have to write out these like type annotations, especially in these where clauses. A lot of people don't in idiomatic Haskell for the most part. But the reason why I do, and I really like to, is because like I really like type inference for hole-driven development, but I don't like it when I'm reading the code. Because then I gotta like figure out what the type of update game errors is sometimes. Especially when you have, it's not so bad in short functions. Like omit, like if you have a really short function, it's only like this, not very long, it's only a few lines, it's probably not that bad. But I find in longer ones, especially like in IO heavy areas of a code base, if you've got 20, 30 lines here, it can be a pain in the butt to figure out where that function came from. Oh, it's an aware block here. I got to scroll down a little bit to find it, and or scan down a little bit. And then like, what's the type of the thing? And it's just nice to have that just there as documentation. It's not really for anything. You don't have to put it there, but it's just nice. Makes the code a little bit easier to read. And sometimes it just helps with Haskell's type inference when you're doing hole-driven development, when you fill in all these types. And then instead of putting in like little generic type placeholders like A0 and A2, it'll know that it should be a game state and a game error. So it's kind of a nice thing. It's a small thing, but it's a nice thing. So bring G into scope. Bring the E into scope. And now we need to return a new game state in this hole. Cool. And then what we had before to get us back into a green build was G with game errors set to the const onto, and we're gonna have to pull this one out because we had it in scope above from a different name, but that's not a problem. We can just do G with the view operator there and game errors. Or no, it's the other way, hat dot. Yeah, setting dots on the left, getting dots on the right, I think is the way, the mnemonic they went with in Lens. Yeah. And that should have the same behaviors we had before, which is nice. So when you're doing a refactor, you want to do it in as small steps as possible. Tiny, tiny little steps. Get back to green as quick as you can. All right, and that's... All right, good. Perfect. And now we can update, we can change the way the behavior works in updating game errors, and we don't have to like mess with all these different places in the code. It's just one here. So we don't want to call just columns on the list and just grow it indefinitely. We have a size limitation on it. So one way we can look at it, if it's a list, we can take the length of it and query the size of the structure before we append to it. Is one way we could do it. Or, oh, we can pattern match on it too, maybe. So let's try that first. What I'm thinking is, right, in this case, right, we could just update G, and this might not work so well, but we'll see. I don't know, game errors, we'll set it to just being the error we got. In the case where we have X and, yeah, no, we have to take the length of it. That's not gonna work. I was thinking like we could pattern match out and then just compose the elements back together, but that seems kind of not good because we don't know the length of the thing here. So, yeah. Let's try it this way. No, I don't like that. I'm gonna pattern match out game state. I'm gonna, pull it apart here. Destructure. That's what I'm looking for. Game errors, I think, is the second last field. Or no, it's the last field. Errors. This way we can have a guard on it. Where the length of errors is less than or equal to 3. No, less than 3, strictly. Then all we need to do is append it, like we did before. Game errors, set to the appended to errors. Otherwise, this is our special case. And this is where we need to we need to take a part of the list, a slice of it. The tail? No. right? That wouldn't work. What am I thinking here? Right, if we just took the tail, that would be kind of like this element here. And then this would be the tail, this part. And then if we took that down here, we'd have our tail, and like consing on our new element would be kind of silly. Because the tail would be the empty list in the initial case, and we would always be depending on this. Well, we append this one element, and then the next one we take. Well, actually, no, that might work, maybe. No, because the tail of one element would be the empty list again. And we append a new element onto that. So we would essentially end up with a list of 1, yeah. But we're only doing this in the case of 3, where we know we have 3 elements. So that would be the last 2 elements. And appending on a new element to the head of that last 2 means we would just basically be replacing the head of the list every time we append a new element, a new error. So that's kind of not what we want, I don't think. I think we want everything but the last element. And our handy dandy data.list model. We have, ooh, no. We might have to just write this quick little function, a little helper function for us to do it. Yeah, something like this. We split it and whatever. Yeah, split it at the second last length -1, and then append the element to the left here, and drop the rest. Is basically what we want. So we'll go to adventure. Adventure. Data. Go adventure. List /utils.hs. Yeah, create the directory, please. And I'll call this append head. Yeah, prepend. Limit. And prepend. Prepend is pretty good. It's probably not taken. We take a list of A, we return an A. List of A. Return a list of A. X and X's. And we're going to, a couple of cases here. Let's just guard. Or pattern match. So on the empty case, we just have X, prepend, where we have anything else. This should be fine. Don't think we even need to guard it. First thing we want to do is split at. We could probably even do this point free. Split at length. Oh no, we don't, because I need to query the length of x's. So x's, length of x's minus 1. If I could spell that right, that'd be great. And we've got to apply that to x's because we're using the dot compose pattern. Okay, so now I've got a split at where I've got the two elements, and with this function, I just want to take the left of the argument, the first. Oops, sorry, what did it want here? Yeah, I wanted to take the first. And then in this function, in this hole, I think I'm just getting distracted by these suggestions here. So in the final hole, let's see, we have a list of A to a list of A. We want to cons X onto that. Can we do it like this? Oh, we don't need a redundant bracket on that. Apply hint, use take. Oh, okay, okay. Yeah, I see, I see. Take. We should probably write a couple of tests for this. I mean, it's just a little helper function. Prepend. If we prepend 1 to the empty list, we get 1. If we get prepend 1 to 2, what's that? And 1. If we prepend 1 to 1, 1. And then again, if we prepend 2. And then if we did that again, 2, 1. We did 3, we should get 3, 2. Yeah. Little helper function. So basically we want to add an element to the head of a list. And the way to think of it is add an element to the head of the list, pushing push the rest of the elements down and pop off the last so that the list is the same length. The output list is the same length as the input. Okay. Import adventure.list.utils and otherwise prepend e to function here. Prepend e to the game errors, and we're going to update the state with that. So we'll do g and game errors set to this value here. We don't need the $sign apparently because I'm awesome. Probably don't need the braces there, the parentheses there. There we go. I'll just rebuild that just in case I didn't catch that because I was editing too fast. There we go. Yeah. Perfect. So 1, 2, 3. 2, 3 elements. That's right. And if I add foof, should be foof and the other two. Yeah, foof at the top and then the other two. Okay, cool. And that's what we want there. Super duper. Boom, another item off the list. Cool, let's check that in. And then, my friends, I'm afraid we are ending. I just want to stage that. We're getting to the end of the stream for this week. So when applied, this change will limit the number of elements, number of errors in the error box to 3. And that's it for this week. I hope you enjoyed hanging out and watching me build this game engine, this text adventure game engine, using the Manomer library and adding a nice vector GUI to it. So yeah, you can do GUIs and desktop applications in Haskell. It's doable. And with a little bit of work, I think we can even make this look really good. You can even have a lot of fun with it. Because under the hood, that's just an OpenGL buffer, baby. We could have a lot of fun with this. And do some neat things, maybe, perhaps. But it can be done. That's one way of doing it. The Manomer library. And that's done. So yeah, cool. I'll push those changes up to the repository on the branch here so you can check those out yourself. And that's that. Thanks for sitting down with me and hacking this week. I'll be back next week, Tuesday at the same time. Again, if you want to join the Discord, the link's up there. You can chat with me during the week. You can follow me on Twitter and catch me there as well. I am Agent Ultra there and on GitHub, where this code is. You can find the code here on github.com. /Agent Ultra, that's me. Adventure Engine. We're on the GUI branch today. And that's what we're working on here. Turning out to be a pretty nice branch. Liking it so far. And you can follow me pretty much in all the places I'm Agent Ultra, except on YouTube, where I am just something else entirely. yaw.com. J. Kenneth King. That's me. Well, this is where I sometimes archive the videos. I haven't been doing that a whole lot lately, but if you're watching, and maybe this one will go up, because I think this is a pretty good session. It might be YouTube worthy. But they're kind of long, and I'm not sure how awesome it is to watch this stuff on YouTube, although my European friends probably appreciate it more, since they don't get to join us terribly often. Anyhow, that's where you can follow the YouTube channel as well. And stuff. Next week, I think we'll maybe wrap up with Adventure Engine on Monomer. Maybe we'll try a different library. Maybe we'll just keep going with this and see how far we can take it. And I don't know. But let me know. All right, tune in. I also want to do another office hours stream as well. So let's kind of tentatively do that maybe next stream. Maybe we'll do an office hours next stream. We didn't get a whole lot of questions last time, so maybe we can do an office hours for a little bit. And if somebody has a question, we'll just stop what we're doing and do it. But otherwise, we'll work on the Adventure Engine stuff. So anyways, may all your monads be free. May your types always check. And we'll see you next week. Take care.